Okay, so this is 4.2, reduction of order in Abel's formula. So the idea is if we're given a second order linear differential equation with non-constant coefficients, so these are functions of x's, if y1, our first solution, is known, and it's a non-zero solution, can we find a second solution, y2, which is independent of y1? So remember, to be a fundamental set, you have to have, this is second order, so we have to have two solutions which are independent. That's what makes a fundamental set. So the answer to that is, of course we can. Why else would I ask the question? Okay, so let's get started. We're going to recall, I have a little bit of setting up to do here. Definition of dependence. So y1 and y2 are dependent if one is a multiple of the other. And the way we would write that, so it's basically one function is just a constant times another. Basic idea of dependency. So therefore, thinking about the opposite, if y1 and y2 are independent, that's what our goal is, then y2, it's not going to be a constant times y1, but a function. We'll call it a function of u times y1, okay? Or simply just y2 equals u y1. And this u is going to be our substitution that we're going to use. So if you solve for u, we're basically going to have u equaling to y2 all over y1. So this is exactly how we are going to start all of our problems. So here's the form that the problem needs to be in. So you can see we are clearing out whatever's in front of the second derivative, and we'll call what's in front of the y prime p of x and what's in front of the yq of x. So given a y1 is a solution, that'll be important at some point, we're going to let u of x be y2 of x. And we don't need to write the of x. I'm just doing it here formally for the first time. y1 of x, which doesn't equal to a constant because we're assuming independence. So just rearranging this, we're going to have y2 of x is equal to u of x times y1 of x.